Hi! Welcome to Big Do, a channel with the purpose to teach kids the amazing world of math and science and how they can apply it. In the first part of this series, we get a glimpse of what computer programming is and a portion of its history. In the next video, we'll go more in depth about the idea of programming, how people use it, and how you can get started on your own coding adventure. Programming, in general terms, means to schedule and perform a set of actions. Whether it be on a radio schedule, a car, or a supercomputer, the concept of programming remains the same. The basics are merely to learn the instruction set you can choose from and how to optimize or make more efficient your instructions. A computer is just a hunk of hardware. It can't do anything unless someone tells it to. And if you tell it to, it follows the instructions so precisely that a single typo could crash your program or your computer. When you code a program, the computer turns it into machine code, processes it, and gives an output. Machine code was made long ago when a bright woman named Ada Lovelace worked with inventor Charles Babbage on a mechanical computer named the Analytical Engine. Machine code was, and still is, very low level, relying on exact coordinates of storage, and using ones and zeros, or hexadecimal numbers, to signify commands and locations. At the time, it was originally written on a sheet of paper and fed into the machine directly. Of course, this was very tedious, and it was near impossible for the average coder to write more meaningful programs in this way. Along came the invention of assembly language. It was a jump in readability because of more natural commands, and with an assembler to assemble those commands into machine code, which the computer could understand. Assembly is still a low-level language because it handles hardware directly. Kathleen Booth is the woman who designed the first type of assembly language and the first assembler in 1947, and in 1948, it was later improved upon. Just a decade later, another great jump in technology took place. Soon, high-level programming languages were made. They had an abstraction from the details of the computer and a more natural format, so programmers can focus on the problem they are trying to solve instead. It made programming a lot more accessible to people. High-level languages are also portable since they are non-specific to any computer. The first commercially published general-purpose programming language, Fortran, is still widely used in scientific simulations and supercomputers. With high-level languages, software may affirm in multiple sectors, including farming, energy production, manufacturing, healthcare, labor, and space exploration. Now you may want to know how you can get into this and make some projects too. If so, then stay tuned for the next part of this series and upcoming programming tutorials, which will be in Python, but can include other languages with user request. Do big, dream big, and stay safe.